Hey guys, Dr. Marino, part 2, sorry for the interruption. We're checking out the amino acid. We stopped at the R group or side chain. Now I said this is the most important part, so the video stopped at the perfect time. And basically this R group will differ in structure depending on which of the 20 amino acids you have. For example, you could have glycine, which is just a hydrogen, or alanine, which is a CH3. Now these side chains could be non-polar, like the ones I just mentioned. Non-polar meaning equal sharing of electrons, it's a covalent bond. You could be polar as well, that's unequal sharing of electrons, again it's a polar covalent bond. Or you could be acidic or basic, depending on if there's a functional group in your R group or side chain. We're gonna check out later in this lab the pH of 3 different amino acids. Hopefully we find that they may differ in pH depending on their side chain. Then we're going to look at denaturation, right? So when we denature a protein, what we do is we disrupt the secondary, tertiary, and quaternary structure of proteins. Notice I didn't mention primary structure or the order of amino acids. And we can do this in different ways. What we're going to do, you could crank up the heat, right? Heat it up. Think about a simple protein. Think about, an egg, cooking an egg white or something like that. When you add heat, it denatures it. It makes it easier to eat. It breaks down the protein structure, so it's no longer biologically active. That's the key, no longer biologically active. It makes it easier for us to chew. Same thing when you're eating your steak. I don't know if you like a nice porterhouse, I do. So when you add heat, this breaks down the tendons, fibers, things like that. It breaks down the proteins, so it's easier to chew on. So unless if you're Rocky and you want to just chug a raw egg, well, you would probably heat it to make it softer to denature the protein. Second thing you could use, organic compounds, right? So organic compounds such as isopropyl alcohol. Before you give a shot to a patient in the arm, they typically rub you with a little bit of rubbing alcohol first. This is to denature the area and basically sterilize it so that there could be no infection or things like that from the shot. Then we could have acids or bases. We'll call these alkaloids. In this lab, we'll look at tannic acid, and we'll talk about what that looks like with proteins and amino acids later on. Then heavy metals, what does that mean? Black Sabbath, no. That means things like mercury or lead or cadmium. These different ions could form things like disulfide bonds in proteins, especially if you're looking at your egg whites, your albumin, which we'll see in this lab. So heavy metals. And the last one is agitation. What do I mean by agitation? Who likes your eggs whipped, right? Your whipped cream, things like that. So scrambled eggs, you are just breaking down the proteins by mixing up the secondary, tertiary, and quaternary structure. It basically just makes it, flat and loose, and it's no longer biologically active. That's the key, no longer biologically active. If you want a good lab report, let's add that. Then what we're going to do is Virex test. Virex test will test positive for peptide bonds. What's in Virex test? First of all, it will be a blue color to start, right? Basically, we have copper-2 ions that will form violet coordination complexes and alkaline or basic solutions. So if we have peptide bonds, or maybe those are in proteins, if we have peptide bonds, Virex test will test positive. It'll turn a really nice violet purple color. I'm looking forward to that. And then the last thing we'll check out is isoelectric point, or pI. The isoelectric point is the pH in which the amino acid has a net charge of 0. Now it really depends on what the pH might be. It could be an acidic pH, or a lower pH, a basic pH, a higher pH. What we're going to look at is isoelectric point and solubility. So we're going to look at the protein complexes and the different things inside your proteins, and we'll look at isoelectric point and solubility. At the isoelectric point, it's very low solubility, right? It's not as soluble. So we're going to look at all these different parts. We're going to check out a protein or a dipeptide. That's 2 of your amino acids connected by a peptide bond. Are you ready to go? I am. Let's go. Let's rock and roll. Proteins. See you in the next video.